All right, everyone. Ow. I'm going to record the class today, which I actually do that in all of my other classes. Like my calculus class, I record every single class. So if this is something that you actually want me to do, I don't mind doing it. It's a little bit extra work, but if today seems like, hey, it was good to go back and watch the video, y'all just let me know. I can do this every day. But I still want you to come to class. That's the thing. My calculus students are going to come to class. They're going to come every time because they want to be there. But I don't want this to be a substitute for you not coming, right? So I will email you later on today, and it'll have a link to the video that I'm recording right now. All right. Now the drawback to it is that I have to stay between this line and this line in order for everything to appear on the camera. So I'm always going to be just working right here. Today, our plan is to cover the 3 problems that I gave you for homework. I'm going to go through those, and then as soon as we're done with that, we're going to start working on the review. We're going to work through it. Probably start with number 1, just go through all the problems. I'm just going to work the whole review out, all right? And then our test is on Monday, right? And on that test, just so we're all clear, it's the same rules as the first test. You can have 1 reference sheet, which is a standard 8.5 by 11 sheet of paper, front and back. You can put any steps, formulas, procedures, quadratic formula, the steps to graph a parabola, that formula for dropping an object, right? All those things, you have to put that on your sheet, all right? Just don't work out any problems on your reference sheet. It's just formulas and steps and procedures. All right, other than that, calculator, just like the first test, all right? Okay. All right, so we are going to sketch this. This is a polynomial function. We went through the steps last class. So let's see how this went for you. First step is what? What do you do? Sorry? LCT, leading coefficient test. We're going to determine whether or not this whether or not this polynomial does like which of those things, right? The end behavior. So to do this, we look at the degree. What is the degree of this polynomial? 6, right? It's the highest power of x that we see, 6. And the leading coefficient is the number in front of that 6. What's the number in front of that 6? -1, right? -1. So our leading coefficient is -1. Now, at this point, you have to refer to the table that we made last class, right? And that table said, if your degree is, let's see, 6, then that's even, right? That's an even number. And your leading coefficient is a negative number, right? Then working off of that table, what would we have? Down, down. Left side down, right side down. So we know that the left side goes down and the right side goes down. If you weren't here last class, you're probably wondering what the hell I'm talking about, but you'll have to get with me if you want to understand that, all right? So down, down? Yes?
Yes, sir.
Good? Okay.
I'm always confused.
That's the first step. Second step. What's second step? X-intercepts. Set this thing equal to 0. So we set the function equal to 0. So we take negative x to the 6th plus 9x to the 4th. We set that equal to 0. And now we attempt to factor the left-hand side. And the first step to factor anything is GCF. So what do these both have in common? They both have an x to the 4th, right? So I can pull an x to the 4th out. Now this is a tricky little piece right here. If you pull x to the 4th out, let's see what we get. You pulled x to the 4th out. How many x's would you need to become x to the 6th? You need 2 of them, two x's, right? But you also need a negative, right? You would need a negative there. So it'd become negative x squared. And then here you took the x to the 4th out, so you would still have the plus 9. Do you all agree with that? That is correct. But if you do it this way, you might not realize that this can actually be factored even more. You might not see that there's actually a difference of squares here. So if I continue working like this, I would have to see that this is 9 minus x squared. In other words, I could change the order of these. And then I could use my difference of squares formula on this. Let me just keep going and see what you think. If I do difference of squares here, I'm not going to get x plus 3, x minus 3. Because the 9's before the x, you're going to have 3 plus x, 3 minus x. Does that make sense? Yes? You sure? Now,
I had a question.
Yeah.
I put negative x to the fourth power. Does that work?
Yes. So this, we can continue doing this, all right? And we're going to get, let's finish this. Let's see what we get. And then I'm going to try it a different way by not pulling x to the fourth out, but negative x to the fourth, and see how that changes things. All right, so set each of these equal to 0 now. Let me continue. X to the fourth, 3 plus x, 3 minus x equals 0. So set this equal to 0. Set this one equal to 0. Set that one equal to 0. And then solve each of these. So the only number that you can raise to the fourth power and get 0 is 0 itself, right? 0 times 0 times 0 times 0 times 0. So x is 0 is this solution here. Here, I would subtract 3, and get x is equal to negative 3. Here, I would probably, to get x by itself and positive, I would add the x here on both sides. That way it becomes a positive x on this side, and it's x equals 3. And those are my solutions. I have 3 x-intercepts. Now, let me see if we would have done it a different way, all right? Let's say instead of doing that, I'll do it in black. What if we would have done this instead? Just to show you, you get the same answer. Going back to this, if we would have instead pulled out a negative x to the fourth, now what you'd have here is x squared, and then here you would need negative 9 or minus 9. Because the negative times the positive gives you negative, and then negative times negative gives you positive. So it would look like this. See the difference between those two? Now, is it easier this way to see the difference of squares? Is that easier? I don't know. I mean, it depends on you. You either have to see this, switch it, and then do difference of squares, or you factor out the negative, and then this becomes negative x to the fourth, then x plus 3, x minus 3 equals 0. And now you set each of those equal to 0. So negative x to the fourth equals 0. X plus 3 equals 0. X minus 3 equals 0. Now, this is the same story. The only number that you can raise to the fourth and then take negative of it and get 0 is 0 itself. So 0 is the only thing that makes this true. And then here, subtract 3 on both sides, you get negative 3. And then here, add 3 on both sides, and you get x is 3. Are those the same 3 solutions? They are, right? So do y'all see it doesn't matter how you did that GCF, it's going to work both ways? Any questions there? No? All right, now, what do I do next? I found the x-intercepts. I have to now determine bounce or cross, right? Do we bounce or cross at each of these? So I'll do it on both of them, just so you can see it's the same thing, right? So at 0, what I do is I go back and I figure out where that came from, right? That came from that factor right there, and the power on that factor is 4, right? And that's an even number. And anytime your power on your factor is even, that means you will bounce. So we're going to bounce off at that x-intercept. This negative 3 came from here, which came from this factor, and the power on that factor is what? What's the power on this factor? 1. And that's an odd number. And that means I'm going to cross here. And then here, this comes from this factor, 1. That's also odd. So I'm going to cross here. Okay? Now, do y'all see we would get the same thing here? Y'all see we're going to get the same thing here? even power, right? This is even off that factor, so that would bounce. This comes from here, that's a 1, so odd. Comes from here, 1, that's odd. You get the same thing, bounce, cross, cross. All right, what's the next step? That was the third step, was to find the bounce cross. So what's our final step? That's what this was. This is called the multiplicity. Yeah. This is getting the multiplicity is determining the bounce and cross. Sketch it, right? Draw the picture, right? It's time to draw the polynomial function. So I will draw my x-axis, I'll draw my y-axis, and I'm going to start my picture by putting my x-intercepts as dots on my x-axis. So at 0, right, I have a dot. Over here at 3, I have a dot. And over here at -3. The next thing I'm going to do is go to the first step where I knew that both sides went down, right? So that means over here, on this side of the graph, my graph should go down, and over here, my graph should go down as well, right? So I'm not going to actually connect it here. I'm going to put the graph like this, and then over here I'm going to put it like this. The reason I didn't connect it to that dot is because I'm not quite sure if I bounce or cross yet. So I don't want to connect it. Like if I connect it, if I did this, and then what if it bounced there, then my graph might look weird because that looks like a sharp corner as opposed to a curve. Remember, all polynomials have to be curved and smooth. I think you could argue that that's not smooth. It looks kind of jagged there. Do you all agree, kind of? So if you draw it this way, it gives you some flexibility where you can draw a bounce if you need to, or you can just cross through if you need to. Make sense? But in this case, when I draw and I connect to this dot, I'm going to do what at -3? Cross. So I'm actually going to come through the x-axis, cross through. And then I'm going to connect, and we're back in kindergarten, we're connecting dots now, right? So we're connect the dot to the next dot. When I connect to here, when I get to that one, I'm going to, that's 0, right? I'm going to bounce. So I'm going to come here and bounce off the x-axis, go back up, and then come back, connect the dot to 3, and then cross through. So when I come through and cross through, I will connect together like that. That's it. I told you last class how high these humps go, or if you have valleys on your graph, how high they go doesn't matter. Okay, so you could draw this one real high and this one real low. That's not important, all right? For this class, it's not important. That's it, we're done. Questions? Sure? Let's look at the next one. X to the 5th minus 3x to the 4th minus 18x cubed. What are you all thinking the hardest part of these problems is going to be for you? Step 2? The factoring and doing that part, yeah. Like the other stuff is just kind of recognizing, solving this and bounce cross, that's kind of okay. Yeah, because if the factoring's wrong, everything's going to be wrong, right? Or if you get stuck factoring, you're never going to find your x-intercepts, and then you're never going to be able to draw a picture, right? Okay, first step here. The degree of this, I'm doing leading coefficient test, right? LCT. The degree is 5, and the leading coefficient here is 1, right? There's a 1 here in front. So when I have a 5, that's odd, and then the leading coefficient is positive. So if you look off the table from last class, what was that? Down on the left, up on the right. Down on the left, up on the right. In the middle, we don't know what's happening yet, right? Second step, set this thing equal to 0 to find your x-intercepts. And now, I guess the most troubling part, right? We need to factor that. So GCF first. What's the greatest common factor? X cubed, right? You can pull an x cubed. Each one of these has 3 factors of x. So I can pull x cubed out. If I do that, in parentheses, I should have 1, 2, 3 terms in here. The first term will be what I need to multiply that by to get x to the 5th. So x squared. What's my next term? Minus 3x. And final term? Minus 18? Okay, there we go. Good? Now you look at what's in parentheses and you see, hey, can I factor that? And that can be factored. Now maybe you need to do it on the side over here. Maybe you need to do this as its own little problem. That's a quadratic, and the way we factor this, the way we at least talked about is we took the number in front here, multiplied times the number in back, that's what? Negative 18, right? And then we take the number in the middle, negative 3, and we have to find two numbers that multiply to be this and add up to be this, which are? Negative 6, positive 3. And then y'all want the real super shortcut that I gave y'all, right? That real short way. This becomes two sets of parentheses. You put an x with a little space in front of it, x with a little space in front of it, and then the two numbers, minus 6 plus 3. Doesn't matter what order you do this, you could do plus 3 minus 6. And then, the last thing you have to do, what do you have to do now? Take the number in front, right here, and put it in front of this one and underneath the other number, or in front of this one underneath the other number, which doesn't matter in this problem because the number we're using here in front is 1. So it makes no difference. This is our answer, right? But on a test, who knows? That might be a 3, and then you'd have to put either a 3 here and a 3 underneath here, or a 3 here and 3 here, right? So we've done that. We've been through that before. But for us, luckily, this is it. Okay, so we are back to this. This becomes the two factors, minus 6, x minus 6, x plus 3 equals 0. And now that's completely factored. We're going to set each factor equal to 0. So x cubed is 0. X minus 6 is 0. X plus 3 is 0. And our first one here, the only number we can cube and get 0 is 0 itself. This one is 6. Add 6 to both sides. And this one is negative 3, subtracting 3 on both sides. All good? What now? What? Huh? What? Multiplicity, bounce cross, right? Bounce cross. So look at this factor, this x-intercept came from this factor. Look at the power here. Odd, right? Cross. This came from this factor. Power here, odd. We're going to cross. Negative 3 came from this factor. Power here, odd. We're going to cross. So it's crossing everywhere, right? At every one of the x-intercepts we're crossing through. So I'm ready for a picture. I plot my x-intercept 0, let's see, 6 is out here, and negative 3 is out here. You don't have to be perfect with the placement of these things. What you need to make sure you do is you put them in the right order, right? Don't put the 6 on the other side and the negative 3 over here. All right, once I've got the x-intercepts, what should I put on the graph next? Yeah, my left and right behavior. And wasn't it down and up? Right? It was down and up. So from this point to the left, down here, I'm going to go like this. And then over here, from that point to the right, up here, I'm going to go up. Right? I know that I have to go down this way. I know I have to go up this way. But I also know that at every one of my x-intercepts, I'm going to actually cross through the x-axis. Right? So I'm going to start connecting dots here. I'm going to start here. I'm going to cross through, go up. I've got to come back to this. So I'll just curve back around. And then I'll cross through again, and then I will cross through one more time, and I will meet up with that side. Everything fit together perfectly. Everything's great, right? What happens if during a test, like let's say we had this right here. Okay. What if we had this? You're sitting there, you're taking the test, you're like, I know what's going on here. This is all good. What if you have this, and you have cross, 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 just like this. And you go to draw it. And you go, okay, cross, right? Come through and cross. And then come through and cross. But wait a minute, I'm supposed to be down here. What is that telling you? That you should just go like that? No. Can't do that because haven't you created an x-intercept that actually is not there? So that should tell you, if you're taking a test and you do that and you get something like that and you know you're supposed to go from there and be down here, something is wrong, right? That means you either messed up your end behavior in the very beginning of the problem, you either messed that up, or you messed up your x-intercepts, or you messed up your bounce cross. So you're going to have to just kind of, that's like a big red flag if something like that happens, understand? So I would just start back at the beginning, just look through everything again. Just don't do that, because if you do that, then you've missed the whole point of this, right? All right, last one. Any questions here? How many of these do y'all want to have on the test? None? How many do y'all like these? Do you? Two? I was thinking two. All right, let's go through this one. All right, so first step, the degree of this one is 4. Leading coefficient is 1 again. And if you look at our table from last class, that means up and up, right? Up and up. Now, second step. Hey, just out of curiosity, not like I would do this to you, but out of curiosity, if this was x to the 5th here, what would the degree be? 5. It's not the first one, okay? You don't get your degree from the first one's power. It's the highest power, right? Just want to make sure you understand that. All right. Okay, so set that equal to 0. Yeah, the degree is the highest power of x that you see. It is not the first power that you see. All right, so there it is. I have a GCF here, right? X squared. If you pull x squared out, you should get this, right? Pull an x squared out of each one of these, so you'll have x squared left. You'll have 1x left there, and all the x's went away there. Then, on the side here, I'm going to see if I can factor this x squared plus 4x plus 4. So I do that little thing again here. What number goes on top? 4, bottom. 2 numbers that multiply to be this add up to be this. 2 and 2. And then you do that little short thing I showed you. And notice we have a 1 here, right? Whenever we have a 1 there, we don't have to really worry about that division thing. So I can say x plus 2, x plus 2? Yes? All right, yes, yes.
Oh, and that's just for 3 terms, right? The whole division thing?
The whole division.
Like when you...
That little shortcut with the 1 here and 1 here, is that what you're talking about?
Yeah.
That's only when you have a quadratic like this that we do that,
Okay.
yeah. Yes. Yeah, I'm probably going to get to your question. Yeah, so here's where we are. I told y'all when I gave you this problem last class, right before we ended, I said this problem is going to be interesting. I'll be curious to see how y'all go after this. If you look at that, right, these are the exact same thing, aren't they? So you might be saying, okay, I'm going to set this equal to 0, set this equal to 0, set this equal to 0, right? I would understand if you did that, but there's a problem with it if you do it that way. Because if you set that to 0, what do you get? What's your answer? -2. If you set that to 0, you get -2 again, don't you? It's the same answer. So do you bounce or cross there? Well, you would look here and you'd say there's a 1 here and there's a 1 here, so you'd say you cross, right? Right? But that's not what we do, because this is the same exact thing as this, and they're being multiplied. What I'm going to do is I'm going to look at it like this instead. It's x squared times this is really x plus 2, but that's squared, right? Anything times itself is that thing squared. You see the difference between looking at it like 2 separate things in one thing? Now, if I set each of these equal to 0, x squared equals 0, and x plus 2 squared equals 0. This one, the only number that you can square to get 0 is 0 itself, right? So this is 0. And over here, just think about it. If this is -2, -2 plus 2 is 0, right? 0 squared is 0. So just by visual inspection, can you all see that the answer to that is -2? Yeah? So x is -2. But now that I've done it, yes? Okay. You could have also set it, I mean, you could have just, there's a lot of things you could do. You could do this, although we did this in the past. We could take the square root on both sides, and that kills off the squared. So you get x plus 2 equals, now the square root of 0 is 0 itself, right? Because the only number that you can square and get 0 is 0. Just like the square root of 4 is 2, because 2 squared is 4. The square root of 0 is 0, because 0 squared is 0. Make sense? Sure. And then subtract 2 on both sides, and you get x is -2. Yes?
So the way I didn't know that you were supposed to do that. But
Yeah.
I just saw that they both bounced, or actually crossed.
Yeah.
I just considered it sort of like well, I kind of considered it being bouncing because I assumed crossing.
Like crossing across would be a bounce?
Would be a bounce.
I guess you could, yeah. If you reasoned that, I guess you got it right that way. But
yeah, would that work every time, or would you just have to?
if you want to look at it that way, you could say that 2 crosses at the same place would be equal to a bounce, and then 3 crosses at the same place would be a cross.
Yeah. So
You could if you wanted to, yeah.
Is it a lot simpler than that?
Does it make more sense to you that way? Okay, then it's simpler for you, yes.
Awesome.
Yeah. I mean, everyone's going to kind of look at it their own way. You have to recognize that these are the exact same answer. This gives you -2, -2, right?
Yeah.
If this was +2 and this was +3, then we don't look at it that way.
Yeah. Plus 2,
Yeah.
Or -2, -2.
Okay, so let's get to the bounce cross. What happens at each one of these? Well, this 0 comes from this factor, the power is 2, so I'm going to bounce. And then this -2 comes from this factor, which has a power of 2, which means I bounce here as well. All right, so bounce at both of those. Bounce, bounce, because of those powers being even. So I'm going to draw my picture. I only have 2 x-intercepts, 0 and -2. Both sides go up. So this goes up and this goes up. And now I'm just going to kind of think through. I draw, I'm going to come here, I'm going to bounce off, come back up, I'm going to bounce off, and I'm going to connect. See, and it's all going to come together nice and smooth. Bounce off, doesn't matter how high I go, so I'll go real high just for fun. Okay, then back down, bounce off, connect. However you want to draw it. Good? Okay, so that's it. I'm going to give you 2 of those on the test. I would expect that the first one is pretty straightforward in terms of the factoring. But be looking for GCF always first, right? GCF. If you look at last class, when we did our problems, you had to do grouping in a couple of those problems from last class. And then the homework problems, you had to be able to do that thing where you figure out 2 numbers that multiply and add. So I guess in preparing for the test, I would expect one of them to involve grouping and the other one to involve this AC method. And I would expect both of them to require GCF. All right? Okay, we're gonna move into the review unless there's any other questions. All right. So before I begin the review, I will say at this point that if you feel like you're completely ready for this test and don't need to sit through this review, that from this point on it's completely optional whether or not you're here, okay? You're not going to hurt my feelings if you need to go or want to go. But if you leave and then you come and you don't do well on the test, it's on you, right? Also, anyone has a specific question over a particular problem on the review because you've already looked at it and you just want me to address that first, then I'd be happy to do any of these problems on the review to start. If not, I'm just going to work through it, number 1, then number 2, then number 3. So any requests?
Could you do number 10?
I can do number 10. So number 10, let me mark it off here that we've done it. Okay. So a ball is dropped from a 300-foot bridge. Find the equation which gives the position of the ball as a function of time. What is the maximum height of the ball? When does it reach its maximum height? And when does the ball hit the ground? Okay, so to do this problem, what do you need? You need the formula, right, that I gave you. So that better be on your reference sheet, right? The formula is d of t equals negative 16 t squared v naught, very good, t plus d naught. That's your master formula for objects that are falling on Earth, right? Where t is time measured in seconds and the distance is always measured in feet. And d naught is the starting height and v naught is the starting velocity or speed. So on number 10, we're taking a ball and we're dropping it, right? We're just letting it go from 300 feet, which means that d naught for this problem, well, I'll put it over here. So in our problem, d naught, the starting height is 300, right? And v naught would be what? Where are you going? I know, I'm kidding. I'm giving you a hard time. All right. So v naught is 0, right? Because we're just dropping it, right? On the next problem, on number 11, we're going to throw the ball into the air. So we're actually going to have a v naught on the next problem. All right. So now, once we've got that, I have not answered part A. For part A, what I need to do is write that formula, d of t equals negative 16 t squared. Replace v naught with 0, right? Replace that with 0, which kills off this term completely. And all I have over there is plus 300. That is the answer to part A. You put it in a box. If you don't box that up, then you didn't answer part A, right? Like if you didn't write that formula down, you have not answered part A. Part B, yes?
What if you just put 300?
That's not the, it says to find the equation which gives the position of the ball as a function of time, right?
I was reading B.
So for part B, now that answer to part B, we don't have to do any work. Because it says, what's the maximum height of the ball? Well, in the case that we just dropped the ball, then the maximum height is what it started at, right? At 300.